This video is focused on how to use or apply rational root theorem in determining the possible rational roots of an equation. Let us define rational root theorem. If a polynomial p of x has integer coefficients a sub n minus 1, and so on until a sub 1, a sub 0, such that a sub n is not equal to 0 and a sub 0 is not equal to 0. F of x equals a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus and so on plus a sub 1 x plus a sub 0, then any rational solution to the equation a sub n x raised to n plus a sub n minus 1 times x raised to n minus 1 plus and so on plus a sub 1 x plus a sub 0 equals 0, known as a rational root or rational zero, can be written as x equals p over q, where p are the factors of the constant a sub 0 over factors of the leading coefficient a sub n in lowest terms. Example number 1. Determine the possible rational roots of x raised to 4 plus 3x cubed minus 2x squared plus x minus 4 equals 0. Applying the rational root theorem, which is p over q in lowest terms, p or the constant is negative 4, leading coefficient is 1. Getting the factors of negative 4 and 1, or since the leading coefficient is 1, therefore we can simplify that we can only get the factors of the constant because negative 4 over 1 is negative 4. Therefore, the factors of negative 4 or the possible rational roots of the polynomial equation are x is equal to positive, negative, 1, 2, 4. Counting all the possible rational roots, there are 6 possible rational roots or PRR of this equation, because there are positive and negative of 1, 2, and 4. So that is 3 times 2 is equals to 6. Another example, determine the possible rational roots of x raised to 5 minus 5x raised to 4 minus 3x cubed plus 15x squared minus 4x plus 20 equals 0. Applying the RRT or the rational root theorem, the constant is positive 20 and the leading coefficient is 1. Since the leading coefficient or the Denominator is 1. Therefore, we will be getting only the factors of p, or the constant, which is 20. Because 20 over 1 is 20. Therefore, the possible rational roots of this equation are as x is equal to positive, negative 1, 2, 4, 5, 10, and 20. Counting all of the possible rational roots, there are 12 possible rational roots, or PRR, of the equation. Next example, 3x cubed minus 19x squared plus 33x minus 9 equals 0. X is equal to P over Q, which is the factors of the constant, and Q are the factors of the leading coefficient. Determining the constant, it is negative 9. The leading coefficient is positive 3. X is equal to negative 9 over 3 equals factors of negative 9 is positive negative 1, 3, 9 all over factors of positive 3, which are positive, negative 1, and 3. Simplifying by getting the lowest terms, therefore x is equal to positive negative 1 over 1 is 1, 1 over 3 is 1/3, 3 over 1 is 3, 3 over 3 is 1. There is already 1 here, no need to write it again. Then 9 over 1 is 9, 9 over 3 is 3. We already have 3, so we don't need to write it again, and we don't need to count the factors that appears more than once. So that is, by counting the number of possible rational roots, there are 8 for this equation. Next one, 6x raised to 4 plus x cubed plus 10x squared plus 2x plus 8 equals 0. Applying the RRT, x is equal to P over Q. P stands for the factors of the constant, which is 8. Q are the factors of the leading coefficient. Leading coefficient is 6. Getting the factors of 8 and 6, we have positive, negative 8, or 1, 2, 4, 8, and for 6, positive, negative 1, 2, 3, and 6. Now let's get the lowest terms of these factors. Therefore, x is equal to positive, negative 1 over 1 is 1, 1 over 2 is 1/2, 1 over 3 is 1/3, 1 over 6 is 1/6, then 2 over 1 is 2, 2 over 2 is 1, no need to write it again and count it. Then 2 over 3 is 2/3, 2 over 6 is 1/3, no need to write because we already have 1/3. Next, 4 over 1 is 4, 4 over 2 is 2, we already have 2. 4 over 3 is 4/3. 4 over 6 is 2/3. No need to write again. Then let's go to 8 over 1, which is 8. 8 over 2 is 4. Then 8 over 3 is 8/3. Then 8 over 6 is 4 over 3. So these are the possible rational roots of the equation, which is x equals positive, negative 1, 1/2, 1/3, 1/6, 2, 2/3, 4, 4/3, 8, and 8/3. Counting all the positive possible rational roots, we have 20 PRR for this equation.